Kitona Tomiwa, and with me are Olagbemiro Olaolu, Gang Victor, Oyekon Korede, and Fiafa Hope. We are in SS2. Our practical is titled Measurement of Degree of Hardness in Water. Water is said to be hard if it does not form lather readily with soap due to the presence of calcium ions and magnesium ions in water. There are two types of hardness. They are temporary hardness and permanent hardness. Temporary hardness is caused by the presence of dissolved calcium hydrogen trioxocarbonate 4 or magnesium hydrogen trioxocarbonate 4 in water. It can be removed by adding chemicals such as washing soda or by boiling. While permanent hardness is caused by the presence of calcium sulfate or magnesium sulfate in water. It can be removed by adding chemicals only.
The aim of this practical is to measure the type of hardness in water. One way to measure water hardness is by titrating water samples with soap solution, and water samples may be boiled or treated with chemicals before titrating with soap solution in order to determine the type of hardness, either permanent or temporary. So materials required for this experiment are burette and retort stand, the conical flasks, our pipettes, the wash bottle, our soap solution, washing soda, our Bunsen burner and lighter, our writing materials, our water samples, which are A. Distilled water, B. Pipe-borne water, and C. Well water. Procedures. Step 1. Fill the clean burette with the soap solution. Ensure that the soap solution reaches the 0 mark point and remove your funnel. Here we have 3 pipettes. A is for measuring the distilled water, B is for measuring our pipe-borne water, and C is for measuring our well water. Start the titration with the distilled water, which is acting as the control. Pipette 25 ml of distilled water into our conical flask and place it under the burette. Start the titration with the soap solution, and remember, when titrating, do not look at the burette. Here, the distilled water only requires 0.1 ml of the soap solution to form lather. Now enter your value in the table. Now refill the burette again with the soap solution to reach the 0 marked point of the burette. Now pipette 25 ml of the pipe-borne water into the conical flask. Titrate the pipe-borne water with our soap solution. Here, exactly 2.4 ml of the soap solution. Put your value in your table. Again, refill the burette with the soap solution. Pipette 25 ml of the well water into your conical flask. Then titrate with the soap solution. Exactly 3.8 ml of the soap solution made the well water to form lather. Record the value in the table. From our table of values, the distilled water used only 0.1 ml of the soap solution. Pipe-borne water used 2.4 ml of the soap solution to form lather, while the well water used 3.8 ml of the soap solution to form lather. This shows that the pipe-borne water and well water contain either temporary hardness or permanent hardness, or both. Before starting the second titration, we will boil all our 3 samples of water. Discard all the content in the 3 conical flasks and rinse with distilled water. Repeat the titration procedure once again, using all the 3 samples which have been subjected to boiling. First, we start with the distilled water. Again, the distilled water only used 0.1 ml of the soap solution to form lather. Also, the pipe-borne water used 0.1 ml of the soap solution to form lather, while the well water used 2.5 ml of the soap solution to form lather. Here, our values have been entered in the table of values. For the third titration, chemical, which is washing soda, will be added to the 3 water samples. Add few drops of washing soda into all the 3 water samples and allow it to stay for some hours. Decant the uppermost layer of each of the water samples into different beakers, and then pipette 25 ml each into each of the conical flasks. Then titrate the water samples each afresh with the soap solution. For the distilled water, exactly 0.1 ml of the soap solution was used to form lather. For the pipe-borne water, exactly 0.1 was used to form lather. For the well water also, exactly 0.1 ml of the soda. Then we enter our values into the table of values. The titration of sample A, which is distilled water and acting as control, remains constant, meaning that it contains neither temporary hardness nor permanent hardness. Sample B, which is pipe-borne water, only contains temporary hardness because upon boiling, it made it to require 0.1 ml of the soap solution, while sample C, which is well water, contains both temporary hardness and permanent hardness. The permanent hardness can be removed by adding chemicals such as aqueous sodium trioxocarbonate 4, which is also known as washing soda, or by adding slaked lime. Thank you.